I'd like to thank everybody for joining us today. Jeff and I are going to talk a little bit about using Lean, but in the automotive industry. So we're going to talk about are you driven for Lean and learning about Lean. So we're going to teach you a little bit about Lean concepts, but from everyday examples using the automotive. So a little bit about myself. My name is Tim McMahon, and I publish a Lean Journey blog. And during the day, I'm a Lean practitioner implementing Lean thinking throughout various manufacturing plants in the fiber optic industry.
Yeah, and I'm Jeff Hajek, and I do the Gotta Go Lean blog. I published a book a few years ago, and about that time I was working as a manager at Fluke Electronics, and I ran their call centers and order entry team. And I left. I had done a lot of Lean in the past, and left and started my company, Valaction Continuous Improvement. And in the last couple of years, I started getting more presence online, and that's how Tim and I met. We were both starting our online presence in the Lean community about the same time, and we just have a lot of similar views. So it really makes a really good back and forth when we start discussing topics like this. So Tim suggested this whole idea about using your car to teach you about Lean concepts, and I think most people, when they talk about the automotive industry and Lean, they really look at it on the production side. And we're taking a little bit different tack in this one. We're talking about specifically about how the operation of your cars provides one more real-world example that you can use when you're trying to teach your team about Lean. And I think the key thing that people forget about Lean is that they're already doing it. And whether they realize it or not, most people use a lot of Lean concepts in their day-to-day life. But let's back up a little bit, and Tim's going to talk a little about the history of Lean and how it came to be in the automotive industry.
Yeah, I think this is a perfect example. We've talked a little bit about some other learning examples that you can see online. We'll cover that at the end of the presentation. But learning through things that you kind of take for granted or that are commonplace to us helps us familiarize ourselves with concepts. And so this idea of taking the car is a great example, because if we look at the history of Lean, this thinking goes back to Henry Ford's era in making the Model T, and looking at various improvements and efficiencies and how you lay out a factory in order to make lots and lots of volume of the product. And of course, we know the famous history of Lean going back to the Toyota manufacturing system, and that's where kind of Lean gets its name from, and all of its credit comes from the Toyota production system. So I think using this car example obviously highlight where the Lean comes from, but also something that we can all relate to.
Yeah, I like thinking about how the Lean progresses through that, and every time somebody gets a good idea, it's used by someone else. When you think about how Toyota does Lean, they actually did a lot of research on Ford, and Ford was one of the early popularizers of the assembly line, the moving assembly line. So Toyota took what Ford was doing and made it even better. And nowadays, when you actually start looking at the companies that are doing Lean, there's other companies that are starting to match Toyota in a lot of ways. When you look at the quality in the latest couple of J.D. Power's initial quality surveys, there's a lot of companies that have actually surpassed Toyota. And what was surprising to me is in the last 5 years, Toyota has only been at the top of the pack one time out of the last 5 years. Hyundai's been up there twice, believe it or not, and Ford and Honda both now have one time listed as the best. And I'm talking about the mainstream cars, not the luxury cars. So there's a lot of transition going on in the Lean community right now, and in the automotive industry is one of those really good test beds for Lean.
Yeah, I think you bring up a good point. I mean, they obviously learn from other companies, and they're sharing their information, Toyota. And I think that's obviously what we're here doing today. And of course, you see this across a number of different organizations and industries now, being whether it's healthcare or service-type organizations. So you're really seeing these principles applied in a number of different arenas.
And that's really one of the reasons why we're teaching it like this, is the more you can take a step back from the direct application, the precise application of how someone else is doing Lean, and match it to your own organization, the better off you're going to be in the long run. So again, that's why we try to do the teaching like this, is we try to give some ideas of how to look at Lean from a different light. And what you frequently find is if you give examples, if I was to come in here and do an order entry example, somebody in accounting might be turned off by it. And not so much that they don't believe it works in order entry, they just don't see that leap to the counting. But when somebody looks at a dashboard like this, like Tim's going to talk about, everybody is familiar with this. There's very few people who don't drive, and they can understand the concepts we're teaching here. So Tim, why don't you take it away and start talking about this concept?
Yeah, I think we put dashboard, and I think maybe that has a number of different meanings in an organization, from maybe a metrics board that you have in your factory to some visual factory elements that you might have in your organization. And really what we're trying to get at is a status at a glance kind of scenario. And so you kind of have this image in your car of this dashboard display, which is kind of giving you the where things are at on fuel and how fast you're driving, whether the engine RPMs, and then of course with the new technology you may even have some automated messages in there, like about, in this case, the engine oil life sensor, or maybe you have a thermometer in there and it tells you what the temperature is outside and that kind of thing. So. But what we're trying to gather is information quickly, and you can determine where you're at in relationship to what's going on.
Well, let me ask this question to the audience then. And the question I specifically is, if you look at this dashboard, what's missing from this? If you're to try and run a factory and you have a dashboard like this that tells you your current conditions, what's missing? So you can either type it in the chat or in the questions. But there's something specific that's missing in terms of how would you manage your operation.
Yeah, it makes a good point. There's always that opportunity for improvement, and while you see the status, there might be more that you can add to this. Yeah,
so well, I don't see anybody jumping right now to answer. It's a little harder when you're in online like this to ask questions like that. So I was just trying something new. But the thing that's missing here is the current, the goals and the optimal conditions. So if you're looking at this, you don't know by looking at this, is your RPM where it's supposed to be? And that's the one thing that I see missing from this. If you're running an operation and you know what productivity is at X, Y, or Z, if you know what your productivity is, it doesn't necessarily say whether you're having a good day or a bad day, or if you know this is how many orders came in today, or if you know this is the number of units you've produced. You may know where you are, but you don't know where you should be. And that's kind of goes to that whole daily management thing of being able to compare the plan against your actual. And that's one thing that a dashboard should have. It should have not only the current conditions, but those the targets and the optimal conditions, so you can take an at-a-glance look and know if something's wrong.
Right, and then continuing that thought, I think you also want to look at what the what level at which do you take an action, and what is that action? And you may have several hierarchies of that action that you take based on what metric you might be publishing or that kind of thing. So if we continue this thinking, we can look at another component of the dashboard being a specific item, being the fuel gauge. And we often think of Kanban systems as two-bin system or production card system, but that's not really the only way. I mean, it means signal card, but I think you can also use other means to signal that you need replenishment of some inventory item. So here you see this gauge indicating that type of replenishment.
Yeah, and this is what Tim is talking about here. Is it's hard to see in the image, and I tried to convince Tim to run his tank down to empty before this, but he just didn't want to take that risk going to work in the morning. But what you would see normally on a gas gauge, you see this light comes up, and that's the equivalent of a reorder point. And that's what Tim was saying, is if you have your tank and you hit that certain point and the light comes on, that's the same as having a row of pallets with a reorder point towards the end of the pallet. Now, and the nice thing about the Kanban in your car is you have a limit for the inventory. We talk a lot about in Lean about flowing work and limiting the size of the space you have where work can actually be put. So the better you limit, the less likelihood you have to have people overproduce anything. And in a car you might have a 15 or 20 gallon tank, but on a truck you're going to have a lot more fuel capacity, and it's really sized for what your needs are. And you see the same thing on the shop floor. There's a lot of different factors that go into sizing your Kanban or sizing your levels of inventory. So Tim, what are the things that would contribute to you when in your organization about how you set a Kanban size?
Sure. I think there's a number of things that you can look at. Obviously, you have the straight number of the demand, but what you may have within the demand is it probably in most cases maybe your supplier or customer doesn't practice lean yet and are new to it. You may have fluctuations in that demand level, so that's one thing you have to consider in the Kanban size. And the other thing is really looking at the other side of the equation is how quickly can you replace that. So in this case, maybe you have a gas station close to your house or close to your travel, and you can always get gas anytime you want. But certainly some regions, trucking example, whatever, they might not have that opportunity to get off the road as quickly. So in trucks, obviously, they have a higher demand, and they have less frequent supply, so they have to carry a larger inventory of. So you look at that same scenario in your business as well. Fluctuations in demand, the demand level, how quickly can you replace it, how much capacity do you have to replace it in your factory or service organization.
Yeah, and then like you're saying, that there's all those different factors that go into it, but the whole goal is to, every time you find one of those factors, is reduce it. You start figuring out how you take each one of those things and go after that waste. So if you're, if you're living on a farm, you may have a fuel tank put on your farm. And when I was growing up, we used to go out to a farm with a family friend, and they had about a 500-gallon drum, like that they would bring a truck in, and they would actually have their own gas station on their property. And it was because it was such a long drive to get into town to fill up the gas tank. It was very expensive. So there's like those things like the cost of replenishment and all the different factors that go into that. But the goal is eventually you want to try and get rid of those things in your organization. So if you find a supplier that's unreliable, you start looking for a more reliable supplier, or you help your supplier become more reliable. But you look at these things, anything that you have that's driving your inventory up, you figure out why is it doing that, and you get rid of that barrier. And eventually you'll find you can have smaller and smaller Kanbans, or smaller and smaller amounts of inventory, which frees up your cash and does all those great things for a company.
Certainly, if you don't plan ahead and you run out of gas somewhere on your travel, you're probably not going to let that happen to yourself too many times. You'll learn from that example. So certainly one of the things we do in Lean is trying to identify opportunities, and controlling and setting levels on the inventory is one way to control or make it visible when you have problems. We'll definitely use that. But not all visuals have to be some sort of electronic system. So I think in this case you kind of see an example of monitoring the engine oil, and it's a manual. You either do it by date or you do it by the number of miles, and you look at when your next service is, and you kind of put the sticker in your window. And I think we can be creative in our own organizations and looking at how we use visuals. Not everything has to be some color display that is connected to the equipment or the process. There are not lots of visuals that can be just as effective in a manual form.
Yeah, I suspect you're going to see a lot more challenge with this down the road. If the idea of a little sticker like this in your organization, somehow it's looked down upon. If you use something very simple, like complexity nowadays has this has a very positive nature to anything that you're using technology with, just a very positive spin on it. And I think it's even getting bigger with the generation that's kind of leaving college nowadays. And I'm dating myself now. I transitioned from the young generation to kind of like in the middle of the pack, where I have some experience but still enough time to kind of see forward into my working career. But I see the new generation of workers that are coming in are much more focused on technology. Growing up, I never had a cell phone, but everybody nowadays is constantly updating people and texting and twittering and all the different things that people are doing. It has this very, very underlying mentality that technology is good, and using high tech, the higher tech it is, the better the solution. And I think what you're going to find is as these younger generations of people start getting more and more positions of authority, you're going to see a greater and greater push for technology and solutions. I think that could be a challenge as you try to roll out a visual factory and you think, Velcro with little laminated tags that you flip over. They're going to lose a lot of the the pull from the original lean crop of experts. And what do you think, Tim? Am I off base on that, or do you think that's going to happen?
No, I think there is a struggle there, and certainly there are places for electronic information display, and there's places for the manual. And I think, at least in my experience, a lot of people want to jump to the technology-driven solution. I'm more pragmatic. I like to just try it. If it works, then you can build a solution around it, because I find that obviously in Lean there's a lot of change, so you might put something in place and it may change in a year or two to something different. So building a lot of technology infrastructure solutions isn't necessarily something I'm highly keen on, but again, I'm part of that technology age where we're driven for data and information, so there is a place for that.
Yeah, I'm not that much older than you, am I, Tim?
No.
But I think the other challenge with technology is most people have a very rudimentary knowledge of how to implement technology, and they know how to use it. But what happens is the more you get focused on using technology for your solutions, the less likely people are to make day-to-day, daily improvements on the fly. So when you look at it, and this is seen really heavily in Kaizen activity, when you have a shop floor team that wants to make a change to a process, very often they can just take a couple pieces of metal and have a welder tack them together and create some new fixture and some very, very basic way of making a process improvement. But in the office, people look to technology changes. They look to software implementations. They look to new programming in an Oracle system. And this functionality is something that people just can't do on their own. So it becomes an action item list that you send over to the IT department, and then you wait. And by the time the momentum starts cooling off a little bit, you may not remember why you had it in the first place, or some condition may change, or it just never makes it up to the top of that list in terms of what IT is already working on. So you start seeing some stagnation, and the more you get focused on technology and solutions, the more you run into those barriers to making quick day-to-day changes. Well, like Tim said, I'm going to transition this one for him. There is a lot of place where technology is useful, and here's one of them.
I agree. So what we got here is an example of Jidoka, and I'm not sure how many people might be familiar with this term, but certainly there are a number of terms you can look at in Jeff's companion on Lean terms. He's got quite an extensive library of different terms that you can try to pick up and learn new things about. So definitely take a look at that. But Jidoka is really this automation with a human element to it. So what you have in this case is the airbag for the passenger example. So there's a sensor in there that determines whether there's actually a passenger in the vehicle and whether the airbag needs to be something that's activated on that trip or not. And so on the left you can see that there's nobody in the seat, and so it's off, and it's not going to be deployed when you don't need it. Versus the other example, you can see where it'll turn on when somebody's sitting in that seat. So this is a good example where you're trying to build in the automation into the process to potentially mistake-proof, but also it's not being used unnecessarily.
Yeah, and I like this one because there's two factors to it. One is the safety. If you have a small child or somebody who's smaller in the front seat, obviously you're not supposed to put small children in the front seat, but there's a weight sense in there. So I think there's some window where if a passenger is too small, the airbag creates a risk of injury, and it stops it from that. But like Tim was saying, it's also a cost reduction effort in that if you have a small fender bender, there's nobody in the front seat, it costs a couple $1,000s for the deployment of the airbag. I think it's it's a pretty expensive replacement, and if you don't deploy the airbag, it's one less thing you have to replace after a minor accident. And there's also another example of Jidoka that people are probably familiar with, and this is in your garage door. There's that electric I-beam that when it's broken, the garage door won't close. So if you think about, in the workplace, you have a production routine, and Jidoka is really, when you talk about it, you're really talking about a way in the repetitive process of making sure that the process stops when something goes wrong. So in this case, the thing going wrong, the abnormal condition, is that something's blocking the door, and it would break it if the door came down. So that abnormal condition is recognized by your system, and it stops the process. So if you think about driving as a process, every day your production routine is you drive yourself to work, you drive the kids to school. That driving is your the destination, reaching a destination is your product. Part of the process is opening the garage door and closing the garage door. So when your garage door has an abnormal condition, it stops the process, prevents you from producing poor quality, in its case, which would be damage to your vehicle or delay in the trip. But the other thing that's nice about this system is you'll notice whenever you do have the electric I-beams broken, your light will flash, the overhead light will flash on most systems. So you'll start seeing that, and you'll know right away that there's a problem. When you press the button, the I-beam's broken, it stops, and it gives you that visual indicator. And these are all the great components. The core components of Jidoka is it recognizes the abnormal condition, it stops the process, and it notifies. But there's also some follow-up on that. And that's what people forget a lot, right, Tim? There's abnormal conditions recognized, but you should have something after that. And what do you guys do in your organization when you have a problem like that that's notified or that is?
I think you create a good point here. Is that for some people, I think relate Jidoka with just automating the process and taking the people out of it, and really that is not the intent. Obviously, I think it's important to highlight the human element. So this example is a great one in the fact that it alerts somebody else to come react to the situation to see, why was it stopped. Of course, it brings it to a safe condition for you because it's a safety interlock, but it also provides the light signal to tell you that something's wrong. And you see this a lot in organizations where you'll use this as a means to, again, maybe mostly safety related, but certainly we don't want to overproduce, and we don't want to overproduce defects. So Jidoka is often used as a way to eliminate potential situations like that can cause you to overrun or overproduce something that isn't going to be good quality. Stop, react to the situation. We have this saying in our factory where we say, when in doubt, stop, go find out. It's not good enough just to stop. What are you going to do to also resolve it? And I think that's an important factor to remember.
And there's two components to that stopping and fixing the problem. There's that immediate stopgap. What are you going to do to get production back up and running today? But then there's the countermeasure piece, that long-term, how do you prevent it from ever happening again? And that moves on to the next, to the poka-yoke, and how do you, keep the abnormal conditions from ever occurring? So there's a lot that goes into it. It's a lot more than just having a sensor or automation. We're talking about a good, Jidoka. And this is actually, one of these pillars of the Toyota production system and of Lean is that ability to make more, preventing problems with your processes. And this is Tim got this one up here, the slide up here, and this is one that really is a good way to keep that, to set those countermeasures up in your Jidoka systems. How do you prevent them from happening? So Tim, talk about standard work.
Yeah, I think, whenever we try to create a process or a certain way of doing things, we like to call that the standard. And, related to that is, how do you maintain that standard? What do you do? What kind of information? So you kind of see the owner's manual here of a car. And organizations are full of certain types of documentation, whether it's for some sort of regulation or process in order to do your task. But we all have our systems of documentation. So this is kind of an example of using some sort of written documentation to kind of maintain that standard. Because without a standard, you really don't have a way to detect the abnormal condition. And without that, we won't know whether we're on track or not, whether we're producing defects or not, whether we're doing what's needed. So, this doesn't really cover the elements of standard work like you might expect, but again, you can certainly find more information on that online and certainly through Jeff's companion guide as well.
Yeah, well, you made an interesting point there. So the components of standard work, and that's, I'll talk about it a little bit more in the next slide, but what are the components of standard work?
Well, I kind of like to view it as like the dance steps, the routine you're going to take, and maybe how you're going to do that. So certainly you're going to look at the layout of the operation, where you might move within that operation, the actual steps that you're going to take to do that operation, and then the timing, whether it's processing time or manual operating time, and you're going to look at what this sequence is, and that kind of creates the standard work format.
Yeah, I think Tim and I share a lot of this. There's a standardization is just a matter of locking things in. And you can do different types of documentation, flow charts, checklists and all these different things. But standard work is more of a specific type of standardization. And like Tim said, I use a very specific series of 3 things, and Tim covered them all, but I just say them a different way. But I always say sequence of operations, standard work in process, and balance your production to attack time. So those are the three elements that I always use. And it's it's the same thing that Tim said. I just I've rehearsed this a lot of times in all the teaching and standard work I've done over the years. So I use those 3 very specific ways of saying it for the elements that I use when I teach it. And with the time one, like Tim was saying, let me get this slide advanced. What you get is, you can think about in driving, you have that timing along the way. So if you live at your house and you get out the door in the morning, let's say you've got to go to work at 8 o'clock and you live fairly close, you know that you have to leave the house by 7:37. And if you're leaving at 7:41, the situation is pretty clear. You're running a little bit behind. If you leave at 7:30, you have a few extra minutes. But the more precise your routine is, the easier it is to know that I get on the main road at 7:41 and then I hit the highway at 7:46 on the way in. So what you get is you get this series of waypoints along the way. Now, what happens if, what's the reason you would have for being behind or ahead on these waypoints?
Certainly you run into traffic or various other scenarios, maybe you ran out of gas, you weren't in a gas gauge.
You don't have that truck gas tank on your car, huh?
No.
Yeah, so the conditions happen in that you have these negative implications of, something negative happens, you're late, you're delayed. But if, in this case, it's very hard to get ahead of schedule. You may hit all the lights and pick up a minute or two. On the drive into work, you're more likely to be delayed than you are to have this perfectly smooth flow. And it's all the distributions and all the statistics that go into that. But generally speaking, you're not going to be able to leapfrog ahead of your drive to work. But on the shop floor, it's kind of likely at times if you forget a step, you may find that you're ahead of schedule, right?
Sure, you might. I mean, certainly being ahead sometimes you may view as a good thing, but it may not necessarily be. You generally want to produce at the same rate every time. That creates that even flow. Mm-hmm. And if you're going, faster or slower than that, those are both opportunities to pause and understand why. I think people forget that it's not just the negative side of the equation that you want to look at as well either. But there might be a best practice there. You might, maybe you make this route really quick and you learn a new way to go and you set that as a new standard. That would be okay to consider that, but certainly, maybe you just got lucky one time with hitting the lights and it's just an abnormal situation.
Well, you as you're doing standard work too, there's a couple things that all flow into this, and my mind starts racing ahead as we talk about this. And I'm reading out of the crisis now. I've read parts of it before, but I've finally broken down and pulling it out and reading it cover to cover. And Deming's got a lot of great things that he talks about, and there's a few things that I disagree with him on. But for the most part, almost everything Deming says is spot on. And one of the things he talks about a lot is this variation in systems versus variations in people. So when you look at the standard work, like in this drive right here, it doesn't matter if you're driving a Ferrari or, a Prius. You're limited by the speed limits of the road, right? So you have some system in place that's taken out some of the imbalances in the capabilities of the person, or in this case the car that's doing the system. On the shop floor or in an office production system, a lot of those individual variances show through. So somebody who's just a little faster, a little better hand-eye coordination, starts to do things a little bit faster. And part of the job of standard work is not so much to take everybody to the same level. It's to create a system where everybody can perform the best in making sure that the system doesn't cause problems or cause errors or keep you from overproducing. So there's a lot of things that go into standard work, and it's a very complicated subject when on the surface it seems pretty basic. So what do you think, Tim? I mean,
No, I agree. I think it's something that we do practice a lot in our lives. We have certain routines of things we do, and maybe we don't view it as standard work, but those routines are really there so you identify problems. So when something doesn't go right, you immediately know and you react to it. And that's really the core basis for wanting to do standard work. It's not to make everybody robotic and everybody the same, but it's to help us identify when there's situations that we need to react to before it becomes too big of a problem.
You talked about the robotic piece, and that's one of the things. And next week or next month, Tim and I have been trying to decide what we're going to talk about, and we're thinking about talking about how to start on a lean initiative. And one of the things that people get turned off on about lean, and this is from the frontline perspective, is they see it as a way of turning them into those robots that Tim's talking about. So people start hearing the word standard work, and they start hearing standardization, and they feel like their job is going to become less fun, and it's going to be more challenging for them to go to work and feel like they're going to be facing monotony day in and day out. And I think there's two ways of looking at it. And one is that the process is much more regimented and it's much more structured, and there is that degree of monotony into it. But when you have standardization built in, you open up a whole lot of other opportunities. You let people start being able to do more job rotation, because now you can learn several different tasks much more easily when they're standardized and your workstation's built to support the flow of the work. And you also get this opportunity to make improvements. So once you have something standardized, you're no longer chasing a moving target and getting better. So Tim, do you see any of this from your employees? Because you've been on your lean journey for a while now in your company, right?
Yeah, I think you initially have some issues with people trying to understand, but as they, come to terms with really what the meaning is and not what they've heard somewhere, but what we really, say it is and believe it is, you find that the creativity and the morale really comes from the improvements you make and not necessarily how many widgets you might produce, like you might have looked at in a traditional setting. So-and-so can produce so much, it's okay, but there's a place for that, and we want those kind of people, but we also want the creative problem-solving solution-type scenarios. And we really see a lot of creativity and energy related to that.
And that's one of the things that Deming says that I really love what he says. He talks a lot about pride of workmanship. He talks about giving people the opportunity to be proud of what they're doing and to feel like they're making a big impact. And you don't get as much of that when you're just trying to follow a random process, but when you make improvements or you make the company better or you find a way to save money and at the same time reduce your own personal frustration, that's where people, when I've seen people get the most job satisfaction in the lean environment, it's when they have control over their work and they have the opportunity to make changes and some autonomy in what they do in their organization. So that's a really long discussion on standard work, and like I said, it's such a complicated topic with so many layers. As you peel back the onion, there's so much that goes into getting a condition where standard work can be effective. And one of those things to make standard work effective is to make sure that your machinery runs.
Yeah, I think anybody who has a car knows they got to do some sort of maintenance on it. Even if you're not a car enthusiast or an auto mechanic, there's some level of maintenance you do, whether it's adding the windshield wiper fluid or even topping off the gasoline and things like that. Looking at that one, you got to change the oil. So while you may not change the oil yourself, there's some level of maintenance being done. And it's kind of what we're looking at with total productive maintenance is who does what based on their interaction with the process. It's not necessarily the skill sets, because I kind of believe that people can be trained to learn certain types of skills. And I think in this case, while I'm not an auto mechanic, I'm not going to repair the engine. There are certainly things I'm comfortable with looking at with the car, whether it's windshield wipers all the way to checking the oil and things like that. And so you kind of see in the owner's manual here some sort of pictorial of what type of maintenance needs to be done and when, what frequencies, and then where to look for it in the owner's manual as to how to get it done.
Well, I'm gonna alley-oop you here and give you one. The total. What does the total mean in total productive maintenance?
Yeah, I think a lot of people like to view total productive maintenance as like operators do all the maintenance, and maintenance doesn't do any maintenance anymore. That's really not the situation. It's to have a comprehensive, like in Lean, where we don't want to optimize individual buckets or individual departments of things. You use a value stream to maybe look at the whole process, the total concept is similar here. We're looking at the entire process and the maintenance and everybody who interacts with that. And, a lot of the maintenance traditionally might be done by people in these traditional maintenance roles. They come in and fix it when you repair it, when it breaks down kind of thing. What we want to be looking at is preventing these failures and understanding the equipment. And so I kind of view the total as, the people who are firsthand using the equipment process. They're your first line of defense. They know all the tweaks, the bells, the whistles, when it runs well, when it doesn't. They're your eyes and ears for really the process. And so I kind of view that as everybody included, looking at the entire process.
Yeah, like what you just said there is, the person who's using it every day, when they start seeing that responsibility on maintenance is also theirs, they start noticing things that are a little different. So when a machine starts vibrating a little different, or they notice that the cuts aren't coming out as smoothly, or their computer is running a little slower than normal. And maintenance doesn't just have to be on, a big machine. Your printer needs maintenance, and your computer needs maintenance, and it goes across the whole gamut of anything that you're using, even like hand tools. Make sure that they're all in top condition. So the total, like Tim is saying, is it's across the organization involvement. But there's also a point on maintenance in that there's a big mindset change with lean, and an organization that has not been doing lean and not having the same type of principles in their underlying corporate environment or culture, they don't tend to see making improvements as part of an employee's job, so they don't build time into it for that. And they often don't see maintenance as part of an employee's job, so there's no time built into it for that. So if you look on this checklist, if you're responsible for doing maintenance 1, and there's what do you have on here, 6 different dots, you can't magically expect people to get those 6 dots done. So you have to be able to go and give them time to get these things all completed, or else in this case, your car is going to fall apart if you never change the oil. You're going to be able to run, and if you're busy taking the kids to school, or you're running late all the time to get to work, you may not feel like it's important to change the oil any given morning. But if you don't do it, your car is eventually going to break, and you're going to have a big problem and a big cost, and you're going to be late for work at some point. So the key here is you make sure you build this into your daily routine. If you give somebody a task as a manager, you have to be fair, and you have to give them the time to do the task you're asking them to do.
Yeah, I agree. I think that's one of the traditional stumbling blocks of implementing TPM is, well, you have to do your 8 to 5 job, but we also want you to squeeze in all these other things. I think, allowing the time to both learn the task and then do the task is an important part of supporting the lean journey.
And when you really think about lean, if you talk about let's do a stand-up meeting in the morning, okay, that's 5 or 10 minutes. Let's do your morning, 5S and getting everything done, another 5 minutes. Let's do your TPM, another 5 minutes. Let's have everybody work, 5% or 10% of the week on projects. That's another couple hours gone. So when you start thinking about that, there's really less production time in a lean company than there is in a non-lean company, because you got all these other tasks that you're doing. But the return on that time is immense. So if you don't have machines breaking down, you're going to get more production out, and you're going to have less overtime. And a machine failure doesn't just affect you; it affects all the people upstream and downstream, because the upstream people can't keep sending work if you're backed up, and the downstream people get starved for work if you get stopped. So a maintenance failure can be hugely problematic for a company, and it's not just the one person; it's everybody.
No, I agree, and I think much of what we do in lean is about making things predictable. So you look at this case, and like you say, you may have the situation where the equipment's going to fail if you run it. And so what we're trying to look at is minimizing the downtime and the failures so that it doesn't risk the equipment, but it's also in a predictable manner so we can plan for it and help level load the production demand, so you don't have to have feast or famine because your equipment's up today but not up tomorrow kind of thing.
Yeah. And that kind of leads into this next one. You talked about predictability. And one of the predictability things is when you have a machine that doesn't necessarily suit your process, people start trying to work around it. So if you've ever looked under the hood of your car, you may notice what this is. And this little fitting here, this little part, I don't know if you can see the mouse or not, but right in that area there, what that is it's a connection point for when you're jumping your car. And in the old days, back, Tim may not remember this because he's so much younger than I am, but the cars never used to have these, and what they would basically tell you to do is that this would say grounded somewhere to the chassis. And, a lot of the chassis is painted, so you got to look for the good point, and then you start worrying about, am I near fuel lines, am I in the spark? And, so there's a lot of, if you're not really familiar with automotive, working on your car, even jumping a car can be a little confusing. But now what they did is they put this in here, and they say, here's a specific point to connect the jumper cables to. And this was actually a modification done by the manufacturer of the cars. But I'm a big advocate of when you have a machine and the machine doesn't necessarily suit your own process, you modify the machine. And I always like to put up a warning whenever I say modify a machine. And that's, always make sure that a person who's modifying it is competent to do it and that you're not violating any OSHA standards or any, breaking any laws when you're doing it. But there's nothing saying that you can't, change the way something is laid out or, create new shells. Years ago, I worked on a machine in a TPM project, and it changed the machine. The tools were automatically changed, and there's a whole conveyor of tools. Excuse me. And after you changed them out, they were dripping with coolant fluid, and they would drip onto an electronics panel. So we just built a little. We just modified it and put a little slide out. Excuse me. We put a little slide-out tray in there. And I'll let you take over for this for a minute, Tim. I'm getting a little hoarse here.
No problem. I think, what's important to recognize is that they kind of looked at the voice of the customer here, We certainly see that in our processes and obviously with Lean is, there was people out there that wanted some modification of the car. Maybe they modified it themselves, but they kind of, a lot of manufacturers took it upon themselves to look at this as an opportunity to add this value to every customer and make it part of their standard platform, and so they've done this. And so, I think there are probably opportunities for you to modify, things in your processes and to look at internal customers as well as, obviously your end customer and see if that's something that can add value to them and increase your value proposition to them.
Okay, and then, moving on to that, modifications. I can't think of a smooth transition here. I think this is our last slide, but it's always nice to be able to transfer them in. But this one that was an afterthought on this was the whole concept of gauges versus poka-yokes. And I think people always want to build in quality into their process. And they want to get things made so that you can't possibly make an error and that you can't possibly produce poor quality. And this here is I'm a little embarrassed at the salt all over the back of the car here, but it's been pretty snowy out in Seattle for a few days. We just haven't got the car washed. But this is a backup sensor. And what this does is, it lets you know if you're about to make a mistake. And it gives you an audible warning that, it senses how far away you are from an item and tells you how close you are by the frequency of the beeps. And this is pretty standard on most cars nowadays. But it's a gauge, and it doesn't stop you from bumping into something, so you can keep backing right up into it. Now, poka-yoke, on the other hand, will prevent you from making that mistake. And we talked about a couple of these other ones earlier, but in this case, there's on a sliding electric door on a minivan, you have a little, this part right here is actually a sensor. And if it's pressed, presumably when the car door is closing, if something gets pinched in there, the pressure makes the car door reopen. And it keeps it from closing on any items that are sticking out or any kids that are climbing in or out of the vehicle. So this actually prevents you from making that mistake. And that's an important distinction because a gauge is good, a poka-yoke is better. So the more you can make your systems prevent mistakes rather than just indicate of a mistake, the better off you are in your organization.
Yeah, I agree. I think the car is full of a number of various examples of, mistake proofing, obviously because of the safety concerns related to running an automobile. But there is a big difference between just putting in some sort of indicator of a problem occurring versus one that prevents you from making that defect mistake. And you definitely want to err on the side when it comes to safety of making it impossible to make that mistake occur when it comes to safety.
And I got caught in my own trap here. I actually took a picture of a gas cap. And what's the poka-yoke on a gas cap? I just didn't put it I didn't make it into the slideshow. I forgot to put it in, but I took the picture. So what's the poka-yoke on a gas cap? There's actually two of them that I can think of. Anyone?
Well, you certainly have the tether, right?
Right, right. That's a big one that you can see easily.
Yeah.
And then nowadays a lot of them have the over tightening one where it clicks so you can't damage your gas cap when you put it on, and to make sure that you put it all that you go all the way on. You hear that clicking when you go into it. I guess it's more of a gauge on that part of it than a pokey yoke, but because it clicks to let you know you're on securely. But the tether certainly is a very low-tech pokey yoke, and the mistake I was talking about, when I fell into my own trap, was that all the examples I have here are very high-tech examples. They're not something that you could do easily on your own in your company. There actually are companies that create electric eyes to let you know that you've broken the beam and make sure that you can't advance a line until you've gotten all the parts picked. But that's something that's hard to do on your own. Now, if you have a problem with dropping a screwdriver into a piece of equipment, it's very easy to tether it. And it's a pokey yoke that you can do on your own very simply that is going to prevent problems from ever happening. If you have a problem with dropping things onto a car, if you're a car manufacturer and you're scratching the paint, you can come up with ways to either tether your tools like we talked about, or you can put a nice drop cloth over the paint ahead of time that would prevent you from actually damaging the paint. So these are all different ways of using very low-tech pokey yokes to prevent problems.
Well, I think that's why lean is all about thinking, right? It's a people thinking system. So I think these are one of the things that you got to consider is what is the right solution for the right problem at the right time.
Exactly. And that actually concludes this presentation now. So we've wrapped up, the content. Now, next month, Tim and I are getting away from this real-world lean. So, this is the third one in the series we've done of talking about how can you teach lean topics using real-world examples that people can relate to. I think we've given enough of those in the last three. And we started out talking about coffee and how does making coffee give you those lean principles. And then we talked about milk and the whole milk delivery system and now the automotive industry. So the goal of these three was really to give you a way to teach lean to your organization or to really relate to it and understand that you probably already are a lean thinker and to get you on that track a little bit quicker. But I think we've kind of gotten those points made. So the next thing we're going to do is we're talking about how to start building up a lean initiative in your organization. And even if you've already been lean for a while, this can help you take a look and see, do you have the right infrastructure built and you have the right core principles in place to make your organization work really effectively. So, for following up with us, if you have any questions, you can get in contact with me at my website at GottaGoLean or fullaction.com. And Tim, why don't you talk about your site?
Sure. I think if you want to continue to learn about some of these examples, you can either go to Jeff's site or my site, and there's definitely lots of practical examples and terms to follow up on some of these learnings. But to continue that point, I think we'll try to provide some practical advice from our experience on some lean initiatives going forward. And, maybe we'll come back around to some other examples in organizations and everyday examples as well.
Yeah,
but again, I think, this is an opportunity for us to kind of, whether you're experienced in lean or just starting out, to try to share some things that we've experienced, learned, and, share those with all of you.
Yeah, I'll talk about Tim's blog a little bit, and he's actually got a really good writing style, and one of the things that I'd say is probably the most impressive about his blog is that he's very constant in how he publishes. So you get a lot of part-time bloggers who have a different job, and they don't stick to a schedule. But he's got a Friday quote that he does every day, and he does his roundups regularly, and he really keeps on his schedule. So if you're looking for that healthy, continuous dose of lean, I do recommend Tim's blog, and I use the iGoogle, on my browser, and I got his blog up there, so I can always see the quick, what are his last three blogs, and I'm a pretty regular reader of his site too, and so I do recommend it. And then the final thing is, we'll just put this up here. But you can get a hold of us each at our websites, and we got a couple phone numbers here for you. Now this presentation, we're going to go ahead and post it on YouTube, and the other presentations I mentioned are already on YouTube also. and you can find them through either Tim's site or my site. And you just go, if you go to YouTube and look for Valaction or Valaction videos, you can pull up all the history of our previous presentations. So with that, open up for questions. I'm pretty sure if you had them, you would have been asking them already. But any comments or questions now?
Well, while Jeff takes a look at what questions we have, I'll just add to that. I mean, if there's questions you have about lean or various things you're trying and you're just looking for some advice that might give us both a lead in for a nice topic in the future, but feel free to contact us, and we'd be happy to see what we can do to entertain those ideas. But that may also help us fuel some discussion on future forums that other people might also benefit in.
Okay, so this is a first, no questions at all. I guess that means we either didn't engage the audience very well. Oh, great presentation, thanks for sharing. So that was a nice one. So I was about to say that, when you don't have questions, you never know. That's the downside of webinars like this, or, you can't look into your audience's eyes and see, are they following what you're saying, are they agreeing with you, disagreeing? Normally in a live presentation you can see that a little better. But, the questions are a good one. So, I'm getting some nice comments here for posting links, and nice presentation. I enjoyed it. Thanks. So I appreciate the feedback on it. That's always nice to hear. So I think with that, we'll go ahead and wrap it up, and we'll get it posted up on YouTube before the next presentation, and we'll start sending out the notes about what the next ones we have are. So thanks again. We really appreciate it.